Hello, hope you're having a good day today. We're going to go ahead and finish up section 1 in your textbook. And today our goal is basically to find out what a geometric mean is and basically take that back to the picture that we were working on yesterday, okay? So at the end of this, this will kind of tie all together, and I think you'll find this is kind of neat. Okay? So the geometric mean between two numbers, okay? Well, mean, you guys know the mean. Let's just kind of take a little sidebar here and just say, well, what do we know about the mean? If I said the mean between 5 and 15, everybody in here would say, well, that's 10. Okay? So all that is an arithmetic mean. Okay? So a geometric mean, we set up a ratio, basically. So we're going to say, well, 3 is the smallest number we have, and 48 is the largest number we have. Okay? When they give you that setting, they're giving you the smallest and largest numbers. And basically, the same number is in the middle. We talked about 3 and 8 are the extremes, or 3 and 48 are the extremes. And I have some number that works for both of those and creates a ratio that works. Well, excuse me, we'll set up a proportion when we can figure that number out. X times x is x squared, and 3 times 48, well, that must be 144. Take the square root, x equals 12. All right. Well, let's see. Does that make sense? 3 over 12, is that the same as 12 to 48? Heck yeah, they're both 1 to 4 ratios. So that's it. That's basically you found a geometric mean. You're finding one geometric mean is what we're going to do, and then that number is 12. So 3 over 12 is the same as 12 over 48, and that's your process. So let's practice this a couple times. So 9 is my smallest number. 16 is my biggest number. All right. So let's see. 9 times 16 is 144. Yay. That makes life easy because now x squared is 144 again, and x equals 12. Take the square root of both sides. Okay. Let's look down here at 6 and 8. 6 and 8. And again, it's got to be between those numbers still, right? So 6 is over x. X is over 8, so it should be in that tight little window there. So x squared equals 48. X equals the square root of 48. Simplest radical form. Okay, let's see. I know that that's about 7 as a decimal, which would make sense. Let's see. 48. 16 goes into 48. So 4 times the square root of 3 would go into both of those spots for x. 10 times 32. So I'm still going to keep going with this format just to get you used to it. So 10 times 32 is 320. And actually, I'm going to not find the biggest perfect square in here to give you a practice on that. I can definitely see that 16 goes into 32, so it probably goes in here. So let's see what happens with 16. So take the square root. So I'm going to go ahead and break it into 16 and 20 to start. Because you don't always find the biggest perfect square to start, right? That's not realistic that you're always going to find that number first. Maybe you do, maybe you don't. So now, x equals 4 times the square root of 20. And I say to myself, self, is there any number, perfect square, that goes into 20? And 4 does. So we need to keep playing with this. And I'm going to go ahead and do this in red over here on the side. So this becomes the 4 that I have on the outside written there, times square root of 4 times the square root of 5. I broke 20 into 4 times 5. So now this is 4 and the square root of 4 is 2. My operation is multiplication. And then 4 times 2 is 8 times the square root of 5. And that's your final answer. Alrighty. So let's go ahead and keep going here. Go ahead and move into a word problem, which is you just kind of have to think a little strategically, but it's not too bad here. We got basically the geometric mean is 52. So I know, I'm giving myself a little bit more space here. So I know these two numbers are 52. One of the numbers is 208. Well, since 208 is more than 52, then kind of has to go there. All right, so my unknown is there. And there's your setup. And so 208x equals 52 squared, which turns out to be 2704. Divide, and x equals 13. And then you can quickly see, yay, 13 over 52, that's a 1 to 4 relationship. 52 to 208, that's a 1 to 4 relationship. So my ratio holds. I must have done it correctly. All right. And now we're going to take this into this picture where we basically can identify uh, basically three triangles. One, we'll call this triangle 1, call this triangle 2, and call the whole thing triangle 3. All right? So we're going to work in this, and we're basically going to be working with legs. So in the big triangle, we can say that this is the short leg, and this is the long leg, and this is the hypotenuse. And all three triangles are similar. So the triangles that we're going to be working in today, all three are similar. So basically, we're going to use this idea of geometric mean. This ties right back to what we were doing yesterday. So let's see how we can set up some ratios here. Okay, this is actually pretty cool. All right, and this is how it all ties back together with the lesson that we had yesterday. All right, so let's go ahead and let's set up some ratios. Okay, so I've got three similar triangles here. So basically, AD to BD. So in what we call triangle 1, that is basically the short leg to the long leg in this small little triangle over here. Okay? So I'm going to go ahead and label that short leg over long leg. And then I'm going to erase my marks. Okay? Because now they got to give me one of the two pieces in the other triangle. So some other triangle, it's either going to be triangle 2 or triangle 3. BD, okay, is right here. As to what? Well, that's if it's short leg on top, this has to be the short leg. So what's that the short leg in? That's in short leg in triangle 2 right here. So that must be, again, short leg to long leg. I have to be consistent. So DC must be what goes there. All right? And that's how you do that. You have to identify what are the three short leg, long leg, hypotenuse, and then you go from there. So let's try this again. Once you do this 3 times, I think you'll be all set. So let's start over on this side with the AB over AC, because that's the one that's all set up for us. AB is the short leg in the big triangle. And the reason I knew that the big triangles was looking at is I already seen that AC is this hypotenuse in the big triangle. Okay? All right? So now basically, my question is, well, AB, what is it the hypotenuse for? It's the hypotenuse for this triangle 1 right here. So what's the short leg in triangle 1? AD. Okay? And that's your logic here. You got short leg, long leg, hypotenuse. What triangle am I in? And then you just make, again, this goes back to your skill of being able to set up ratios that we've worked so hard in chapter 7 to get for you. Now we're going to apply that again. So let's try this a third time. DC, let's mark that, over BC. Well, in triangle 2, that looks like the long leg over the hypotenuse. Okay, so I'm going to mark that. Okay, and let's see. Blank is to AC. Well, where's AC? Let's see. AC is the hypotenuse in the big triangle. Okay, So I must be looking for the long leg in the big triangle. Well, that must be BC. And if you'll notice on all these, I've got the geometric means. I've got the same thing in this spot here, here, and here. And this kind of just confirms, hopefully I already knew BC was going to go there, but that confirms that for you as well. Okay? Got a couple quick problems for you with this, and then this topic is complete. Geometric mean. So how do I use this? 21 is to 9 in triangle 2. That's our long leg to short leg. All right. So now this should be 9 is to x, right? So I already know that, but I should be able to confirm in this little triangle over here. Now I've got the long leg over the short leg, which is x. And everything looks to be copacetic. 21x equals 81, and I get not a nice number here, 81 over 21, and let's just leave it at that. Okay? Last one, last problem here um, is this guy right here. All right? So we've got 8 is to x is to blank. So let's see, what's 8 is to x? 8 is to x, short leg is to hypotenuse. So I must have short leg. What's x the short leg for? Well, x is the short leg in the big triangle. Okay, what's the hypotenuse in the big triangle? 20. So x squared is 160. One last practice at going ahead and being able to take the square root properly. So that's definitely 16 times 10. And why do I like 16? Because the square root of 16 is 4. Simplified, and that is it. You know geometric mean. You know how to find geometric mean given numbers, given pictures, and basically everything about this picture with the three similar triangles you can handle. Hope you're having a great day, and we will talk to you soon.